Hello, I'm Mr. Muskeluk, your AP Chemistry teacher at ChemAdvantage with one of our virtual labs. I hope you enjoy it. Our next lab, the lab with percent carbon and sodium hydrogen carbonate. I mean, it's sort of amazing that in a simple lab like this, we can find out about the atomic level structure and the weight of carbon within this baking soda without having to take it apart. It's a clever experiment. First, we'll need some vinegar. That's going to be easy. I've got my Heinz vinegar here. Let me grab the bottle as I reach across the camera. And we only need about 60 mLs of this stuff. And these markings are sort of hard to see. But this isn't going to have to, we don't have to worry about being, oh, I got lucky. We don't have to be about being accurate. This is just a little bit more than 50 mLs. Maybe just a touch more. There. The acetic acid is going to be in excess. This is 5%. My Heinz is a little bit more than 5%. It's pretty darn good. So there's my vinegar. That's my acid. It's a weak acid, acetic acid. Now we're going to need some baking soda, and it's about 2.5 grams. Let me just write down that I've got about 60 mLs of acetic acid. Okay, here we go. Got my pen. 60 mLs. I've got a table set up ahead of time, so it's easy to do. And I'll put that aside. My next thing is going to be weighing my baking soda. I've got a Slick magazine here, some of my King Arthur Baking Company catalog, and I'm going to zero that piece of paper, my weighing paper, which is pretty classic. And boy, this is working out nicely. Here's my automatic tare, and yeah, zeroed out beautifully. And I need about 2.5. Now, it's about 2.5, but I have to know its amount exactly. So, oh, I've got a new balance here. This balance I picked because its numbers are easier to see. It's also a little bit more accurate than yours, but this is going to be 2.0, 2.1. 3, it's a little bit in excess. Let's get it closer. 2.5. There we are. Oh, 2.535. I'll leave it right there. Okay, that's lucky. I'd accept 2.6, 2.7, 2.3. All those would be fine. Okay, 2.540. I'm going to write that down. Mass of sodium hydrogen carbonate. 2.540 grams. That's a critical weight, so you got to be careful with that. Okay, I've got that in my paper. I don't want to spill that or anything else. I'm going to put my reaction vessel here. It's this big plastic container. And, oh, I know what I have to do. I got to weigh the whole thing because I'm going to see what happens when my vinegar and baking soda react with one another. Now, I gotta tear this. See, set it at 0. Yeah, set at 0. And everything. Baking soda, the paper, the cup, the vinegar weighs a goodly amount. 98.070. And that last value is sort of iffy because I don't have a draft shield around it, but I'll write it down anyway. It's there, and I'm not going to lie, that's what the value is. So this is what everything weighs before the reaction occurs. So let me get this tiered paper away. I'll take my reaction vessel and put it in center stage, right about there, right next to my lab notebook, and I wrote down the amount. Don't forget to write down these amounts, otherwise you have to do the experiment over again. So, okay, 98.07, I've got that. That's one of the nice things about having a table ahead of time. It sort of organizes you. So now comes the experiment, which is sort of fun. This is sort of neat. If you dump all of this in, it's just going to foam all over the place. You're going to mess things up. So you got to do a little bit at a time. So I'm going to add a little bit of baking soda. Oh, it's a pretty foaming reaction here. you get a chance to see it. Love it. One of the reasons baking soda is used in baking is because it makes those bubbles, but they make the bubbles in your flour water mixture as it's baking, and those little bubbles allow what you're baking to have those nice little air pockets in it. Don't want to lose any of that sodium hydrogen carbonate, and make it nice and fluffy. Otherwise, if you didn't end up having a leavening agent, either yeast or baking soda, you'd have flour bricks, which have happened to me on occasion when I've been baking bread, when my yeast didn't work out well. Okay, that's been reacting nicely. Here we go, a little bit more. Getting brave, dumping a bunch more in. Whoa, you can hear it. There. Not sure if you can make it. Oh. Okay, careful. React, react, react. There. And I don't want to lose any of those little grains. I think I can get the rest in okay. How brave do I feel? We're live. It's alive. Oh, excuse me. I'm having too much fun doing experiments. There. Here in chemistry, study of change. We've got the same number of atoms, but these atoms are changing their combinations. So we no longer have just vinegar and baking soda. We've got now that reaction which made a sodium carbonate, carbon dioxide, and water. And the carbon dioxide has escaped from here, or maybe not all of it. Let's do a weighing right now. Oops, come on, react, react, react. Just a little bubble. I think it's pretty well done. Now let's weigh everything right now. I'm going to zeroed, good, my balance is 0. I'm going to put that on there, and don't forget to put the paper back on. This is the second time I've done the experiment, because the first time I forgot to put the paper on, because we have to know what the change in mass of just the chemicals were. Okay, I've got everything else. It used to be 98.07, now it's 96.975. The water that was produced is still in there, but the atoms that escaped were carbon dioxide, and they fizzed out, or mostly out. Let me take this off again, and I'm going to, CO2 is denser than air, so I'm going to do a little bit of blowing to make sure that none of that CO2 is left in there. And again, don't forget the paper, and see what the weight is. Oh, hey, look, it weighed a little bit less. That's CO2 added about 0.06 of a gram. It's 96.90. It was 75 before. 0 grams. Now, the only thing that's escaped has been the carbon dioxide. The products, because we don't have any sodium hydrogen carbonate left anymore. We have some excess vinegar, but the sodium hydrogen carbonate has undergone that chemical change to be sodium carbonate, CO2 gone, and water. So there we are. I think we're set. And again, don't forget that extra little weight in there when you do, if you do this experiment. Don't be like me doing it a second time, but doing it a second time was fun. So there we are. We finished our lab. We just have to end up, I've got my data recorded, everything else. We just have to figure out how to take this all and make sense out of it to find out what the percent carbon is in CO2. It's amazing. This little experiment, we can find out the percent carbon in this stuff. All right, now on to the calculations. Well, here we've just completed the experiment, and you saw how it ran. We got the little fizzies coming in and allowing our carbon dioxide to escape. And now we've got to make some sense of this experiment to see if we could actually find the percent carbon in mass of CO2 and carbon in sodium hydrogen carbonate. Now, a couple of things to sort of look at. Let me get my pen here. I'm going to get a pen and start drawing. Okay, we had our vinegar. In this case, this experiment's case, we had 5% by weight and 60 mLs. Now you can use that to find out how many grams of acetic acid you have, because it was 5% acetic acid. And then you can find the moles of acetic acid from that mass. And you'll find out that the acetic acid was in excess. The real heart of the experiment is that here we had a very carefully measured weight of sodium hydrogen carbonate. And that I've repeated here in my calculation section where it's 2.54 grams. Now remember, this on this balance, so this 0 is either a 0 or a 5. It's sort of an estimate. So actually, in terms of being a reliable value, it's 2.54 grams. Now you could change that into moles and then compare that to the moles of acetic acid, and you'll find out that the sodium hydrogen carbonate, the baking soda, is the limiting reactant. All of it's going to end up reacting. Now back to our data, we had everything, our cup, paper, and you name it at the start of the experiment that we weighed here. That's our 98.07 grams of solution. And we added the baking soda carefully, and finally blew out the carbon dioxide. So we only had sodium carbonate left. And our final weight was 96.9 grams. Now the difference between these two weights is the small amount, the grams of CO2. I did the calculations for you last time, but you can figure out the calculation yourself. It's simple enough subtraction. And again, if you kept it to the hundredths, that would be, I think, an honest way of doing things. Now, you can pretty easily find the moles of carbon dioxide, I hope, by changing grams into moles. By now, you know, divide by the molar mass. And carbon dioxide, you probably already know. We use it often enough, and it's used so often. Everybody knows the molar mass of carbon dioxide. Even Alexa. Alexa, what's the molar mass of carbon dioxide?
Carbon dioxide's mass is 43.99 unified atomic mass units, and its molar mass is 44.01 grams per mole.
There we go. And divide that mass by the molecular mass of CO2, you get moles of CO2. And here's the real secret for the experiment, because there's just one carbon in carbon dioxide. So if we had 15 carbon dioxide molecules, we'd have 15 atoms of carbon. So if you had 0.01 moles of CO2, you'd have 0.01 moles of carbon. And from that, you can find the grams of carbon. And that's it. That's almost the end of our experiment. The final part is taking that mass, because we're going to find the percent carbon by mass. If it is percent by moles, it'd be 1 to 1. So we would take that mass of carbon, divide it by our original weight, our 2.54 grams here, and which is the sodium hydrogen carbonate. Carbon divided by sodium hydrogen carbonate by weight, and then of course multiply by 100 and you'll get the percent. Now I noticed in this experiment that as I was adding the baking soda, there's a little bit of splattering going on. You couldn't see it in the video, but I noticed I was getting I felt and smelt the vinegar as some of that stuff came out. So you'll be able to figure out the percent error on this as a result. So there's your calculation. Okay, very good. I mentioned before that the baking soda is used for baking because it produces carbon dioxide to provide a little bit of fluff for pastries and baked goods. So I decided to experiment with a little bit of baking soda and some a substitute for the baking soda, salt. This is I had a recipe for what was referred to as soda bread, and it has a combination of flour and some baking soda, and you mix it with some egg and buttermilk. Buttermilk's got lactic acid, which is very similar to acetic acid, just has an extra OH on it. And I've got the same type of buttermilk on both sides. The only difference between these two little biscuits that I'm going to be making, soda biscuits, is one's got baking soda and the other one's got salt. And I mixed them all up, did everything identical, and finally ended up getting my two little biscuits that you can end up seeing here. Then I baked them in an oven, 400 degrees for 43 minutes. And you can see the difference between the two. The baking soda one fluffed up noticeably, and also very interesting, got a bit darker. There's an extra reaction that occurs with baking soda as it turns into sodium carbonate. We'll see about that later. The salt version didn't puff up nearly as much because no CO2 is being made. Probably a little bit of water evaporated, causing a little bit of fluff, but not nearly as much as the sodium hydrogen carbonate. And then I ended up slicing them up, and you can see one's really fluffy and the other one is like collapsed, almost a puck. But very interestingly, the collapsed one tasted sweeter, even though it had identical amount of sugar than the other did. And that's worth exploring, and that deals a little bit with our sense of taste and sweetness at the same time. So a little extension of baking soda doing its baking. Okay, that's our experiment.